Hello, my name is Kaspar Krüger and I would like to demonstrate in a few minutes how handy and easy it is to design a port maneuver with SAMMON Planning. And let's just imagine you are the navigator for the upcoming maneuver to the port of Lauderdale. And basically it's the task to enter the sea channel, to pass the breakwater at a speed of roughly 8 knots, turn to the south and then approach the stern by the starboard side until the ship is safely moored. At the beginning, outside here, we approach with the engine telegraph on set 4 and we have a speed of 8 to 9 knots. What we expect is a current setting from the south to the north with about 2 knots. And I set a current of 2 knots and we will see instantly how 2 knots of current will affect our ship's track through the water with a speed of 8-9 knots. In order to compensate that, we need to find a drift angle in order to sail through this sea channel. And let's give it, of course I know, 260 degrees. So which means we have 10 degrees of drift in order to stay in the sea channel. But when we talk about drift, then we talk about a drift of 2 knots and a speed of roughly 8 knots. But what happens when I increase or decrease my ship's speed? How will the current affect me? In the present situation, with the current setting with 2 knots to the north, and we have a drift angle established of about 10 degrees in order to stay on track, which is basically 270 degrees straight in, 10 to 12 degrees drift angle, we can see that we have roughly 2 knots lateral speed at the bow and at the stern. When we go to speed through the water, then we can see that we basically, when the ship is moving through the moving layer of water, we have no drift angle at all, no speed at the bow or at the stern. So when we move through the water, we have a straight motion and no sideways motion on the bow and the stern. But of course, over ground, that's differently. We have about 2 knots on the bow, on the stern, and moving with 8 knots ahead. If I'm gonna increase or decrease my speed now, what will happen? Set 3 on both engines. So I decrease my speed. I'm sailing with 5.5 knots compared to the 8.5 before, and we have a way higher drift than before. So in order to compensate for that, we need to steer further to the port side, and we will have a larger crabbing angle or a swept track, of course, in the sea channel, which limits the space on port and starboard side. On set 5 on both, my crabbing angle or my drift angle is less, and I will end up with a speed of 10 to 11 knots here at the breakwater. So our task is to stay between 8 and 10 knots. So let's go back to set 4. And we sail through the sea channel with these 10 degrees of drift angle until we reach this pair of buoys. Now we have the situation that inside the breakwater we will meet the calm water without any drift. And here outside we still have the current of roughly 2 knots. So in order to estimate the effect of sailing into calm water and still having the current on the stern, we need to initiate a turn to starboard side. Presently, we sail with a 10-12 degrees of drift angle, and if we would hit the calm water right here, of course we would sail straight to the south into the green side of the fairway and then into the shallows. So I give a rudder command to starboard. First of all, over here I have to set a maneuver point, and from here on I'm allowed to change the maneuver to continue my plan. So I give a rudder command to starboard. 5 degrees, 10 degrees, it's a good question. Let's start with the 5 degrees. And I move further inside. So once the ship has entered the breakwater, basically the bow, I set another maneuver point in order to simulate that the current is now cut from 2 knots to 0. and I kill the current. At that moment we're almost lined up for 270 degrees heading and course, so rudder back midships, and we make it further through the sea channel. The next aim, of course, is to reduce the speed and then to initiate a turn to port side. That means we move on, and as we did not change our engine setting, we still sail with a speed of 8.5 knots, which is a bit fast, of course, to initiate the turn, that's clear. So let's go back to, let's say, set 3. 7 knots, still pretty fast. Anyway, I want to keep it to demonstrate different effects of turning or different impact on the turn. I set another maneuver point, jump into that position where I have this last buoy on my port side. And the question now, of course, I'm still quite fast with almost 7 knots. I give a rudder command to port side. What happens? Of course, obviously I turn to port, but furthermore, I expect the ship's speed to drop significantly. Let's give it a 20 degrees of rudder angle, and we here have a prediction of 24 minutes. That's a bit much, so let's reduce it to something like a 10 or 6 minutes. So what will happen? I turn to starboard, of course, to port side, correction, turning to port side, and by turning of 90 degrees, by a heading change of 90 degrees, my speed dropped, let's have a look, roughly by the half. This is just the turn. And now, of course, I can combine it with reducing the engines. For example, if I would have stopped the engines before, just to play through my options, of course, my speed is dropping even further, but my turn is not that radical. So it's quite an open turn to port side, and I'm drifting further to the quay on the west. So I want to end up in the middle to be in a safe position where I can stop, move to the starboard wing, and then approach the pier by the stern. What we can do, of course, is use. Now we have just like the passive steering effect. The rudder is put 20 degrees to port, and we just have the ship's inflow basically that helps us to turn to port side. If I keep now one engine running ahead, of course I also have the inflow or the wake from the propeller itself. So let's split the engines and give on starboard side a command ahead. And on port side, using the shoulder effect, I can pull my port shoulder back. My starboard shoulder is running ahead. Port astern. It is shortening the turn, so the speed is dropping quite fast, and I have a higher rate of turn in order to reach this final position where I wanna change to the starboard wing and continue my maneuver. 2 knots. Let's move a bit further. 1 knot. Roughly 1 knot, that's a good position. Let's set a maneuver point over here and reverse both engines. Both engines running astern, slow astern, or even half astern, and I'm picking up stern speed. So basically this position is a moment where the ship is hardly moving, and I have the time to go to the starboard wing, to test my command, to control, and then proceed towards the pier. Now, as I'm sailing astern, of course, it's very helpful or easy to steer with the bow thruster. And sorry, this is the stern thruster. Yeah. Steer with the bow thruster, and as I'm moving astern, there's no need of having the rudder put 20 degrees to port side. I set it to 0 and had almost no effect. And now I'm able to steer towards the pier. So what you can see here is that before I go to the bridge, before I conduct the maneuver, I can elaborate for myself a plan, and I can try and find out how to get in an efficient way, in a fast way, in a safe way. When we talk about limits, it's of course better to talk about a range. So I want to enter the breakwater with a speed of 8 to 10 knots, because the question is, when can the co-navigator or bridge member start to challenge me? When I plan a maneuver and I present this maneuver to my colleagues in the bridge arrival briefing, I present this strategy that I elaborated within a couple of minutes of trying. And this is what I'm going to try, of course, to carry out the maneuver later. But it will never be the reality is never exactly what I planned. So for me, it's good to know how many meters distance I expect to a breakwater. What is my speed I expect passing the breakwater? And with this plan, I have a very good basis to come on the bridge, put the hands on, and carry out the wind maneuver. Now, to keep it simple, we just had current in this maneuver, no wind, to make this effect more stronger, to point it out in a stronger way. Let's imagine that in this position, I can jump back to maneuver point 3, we would have wind suddenly gusting up, and let's say we have a wind from west. So wind is coming from 270 degrees, and we give it a speed of, let's say, 20 knots.
And where did you see the results?
The results are to be seen immediately. We set the wind and we end up, of course, further on the east side. And what we need to do here is to maintain a higher speed until we initiate the turn, or turn with a smaller rate of turn in order to stay on the western side of this basin here. So we have here the ship model. We have different parameters like wind, like current, or the water depth we can play around with, and yeah, we can set up what we expect for the next port call. So we check the forecast, wind and weather conditions, set up our chart, our system, and then try to find the best way. It's like a little practice-oriented risk analysis. And here you can think out of the box and come up with new approaches, new ideas, maybe